Go's approach to concurrency is, without a doubt, one of its most powerful features. So in this explainer, we're going to break down its core building blocks, piece by piece, from the incredibly lightweight Go routine all the way up to the powerful select statement.
But let's start with why this is so incredibly critical. And this quote, it's not an exaggeration. In the world of back-end systems, mistakes with concurrency are expensive. And when things go wrong, they go wrong fast. So, understanding these concepts isn't just about writing clever code. It's really about building resilient, production-grade systems that don't fall over.
So, here's our roadmap for today. We're going to start with the fundamental problem, then build our way up from the simplest unit, the Go routine, and keep going until we get to the patterns that tie it all together. Okay, first up, why does Go's model even exist in the first place? Well, it all comes down to a massive, fundamental difference in cost and scale when you compare it to more traditional ways of doing things. And this slide just says it all. I mean, look at these numbers. A Go routine kicks off with a memory footprint that is hundreds of times smaller and can switch context over 90% faster than a typical OS thread. This isn't just a small optimization. We're talking about a change that means you can realistically run millions of concurrent tasks on one machine. It completely changes how you think about designing software.
So that brings us to the star of our show, the Go routine. It's the absolute foundation of everything else we're about to talk about.
So what is it, really? Well, put simply, a Go routine is just a function that's running at the same time as other code. But the key detail here is that it's managed by the Go runtime itself, which makes it unbelievably lightweight and efficient. And launching one is this simple, the Go keyword. That's it. This syntax isn't an accident. It reflects a core belief in Go. Concurrent should be so cheap and so easy that you never think twice about using it. So what does all this efficiency actually unlock? Scale. And I'm not talking about managing a few dozen or even a few hundred concurrent tasks. We're talking about the ability to spin up nearly 3 million of them on a pretty standard machine. This is the kind of scale Go was built for. But, with great power comes great responsibility. Every single time you launch a Go routine with that Go keyword, forking off a new path of execution, you are responsible for eventually joining it back. If you don't, your main program might just exit before your Go routine even starts, leading to some of the most frustrating bugs you can imagine. I find it helps to think of a really busy kitchen. You've got a handful of chefs, those are your OS threads. But you have hundreds, maybe thousands of order tickets coming in, those are your Go routines. The Go scheduler is like the expediter, masterfully juggling all those tickets to make sure no chef is ever just standing around idle. Okay, so we've got these tiny, lightweight workers. But what happens when they need to coordinate? Specifically, what if more than one Go routine needs to access the exact same piece of memory? Well, that's when you reach for this sync package. Think of it as a surgical toolkit for very fine-grained control. And here's a quick look at the main tools in that kit. You're going to use a wait group for that join point we just talked about, making one Go routine wait for a bunch of others to finish. A mutex is your classic lock for making sure only one thing can touch a variable at a time. And then you have other helpers like once and pool that solve common concurrency problems, like making sure an initialization function runs exactly one time, no matter what. The simplest analogy for a mutex is a bathroom key. It's just a single key. Only one Go routine can hold that key, or the lock, at any given moment. This ensures that the shared resource, the bathroom, is only being used by one process at once.
But what if you don't want to share memory at all? What if you want to avoid locks entirely? This brings us to Go's most iconic and honestly game-changing feature, channels. And this is a major philosophical shift.
This is the mantra. You need to burn this into your brain. Instead of locking data so multiple Go routines can access it, you pass ownership of the data from one Go routine to another through a dedicated, safe communication line. It makes the flow of data explicit and way less error-prone.
The basic operations are pretty straightforward. You make a channel for a specific type, you send values into it with this little arrow syntax, you receive values from it, and when you're all done sending things, you close it to signal there's no more data coming. Okay, everybody, pause here. This is, without a doubt, the most important slide in this entire explainer. Understanding this table is the absolute key to avoiding painful, impossible to debug concurrency bugs.
Pay very close attention to those red panic cells. Trying to write to a closed channel or closing a channel that's already closed will crash your program. Internalize these rules, and I promise you, you'll save yourself hours of debugging misery.
To make sense of the different types of channels, just picture a factory conveyor belt. An unbuffered channel is like a direct handoff. The sender has to wait for the receiver to be ready. But a buffered channel is like having a little staging area on the belt, which lets the sender and receiver work a little more independently.
All right, so you've got your goroutines and you have channels for them to talk. But how do you manage communication across multiple channels all at once? That's where select comes in. It's the control plane for your entire concurrent system.
And the for select loop is the pattern you are going to see absolutely everywhere in Go code. It lets a single Go routine listen on multiple channels at the same time. It just waits until one of those channels is ready for an operation, and then it executes that specific case. It's an unbelievably powerful way to coordinate complex asynchronous work.
The absolute best analogy is an airport gate agent. They're watching several incoming flights. Those are your channels. The very moment one of them is ready, they jump into action and process it. And if multiple flights are ready at the exact same time, they just pick one at random to make sure everything gets handled fairly.
So let's just pull back for a second and look at the path we've taken. We started with this simple, elegant Go routine as our worker. We learned how to coordinate them the old-fashioned way with the sync package, and then we saw the huge paradigm shift of using channels to communicate instead. And finally, we brought it all together with select, the control plane that orchestrates everything.
It really all comes down to this. Go routines are your workers. Channels are your communication lines. Select is the control plane that directs the traffic. And the sync package? That's your surgical toolkit for those tricky edge cases. Each piece has a very specific job, and together they form this incredibly cohesive, powerful system for writing concurrent programs.
Look, this isn't just a collection of features. It's a completely new way of thinking about hard problems. So the real question is, now that you have the toolkit, what are you going to build with it?